Do what? I'm sorry.
17.
Sure.
My mouth hurt.
Your mouth hurts? I'm sorry, bud. Okay, so 17, you got the apothem because it goes from the center to the side. Hey, buddy, go put that in the sink, okay? So I'm going to do it on this side just so it won't get messy. We're trying to make a right triangle. And so we have one measurement. In order to start getting some other measurements, you need to find an angle. And the angle we know how to find is the central angle. So what would be the central angle for that shape?
Wait, is that then like 360 over the number of sides?
Yes.
Okay. 45.
So 45 is going to be, we'll do it in that same just so we'll be consistent, would be if you went from a vertex to the center to a vertex. So that would be this whole angle. That green triangle that we're trying to use, the little right triangle, is going to cut that angle in half. So what's the angle inside that little green triangle?
22.5.
Yes. 22.5. All right. So now we want to use that triangle. And I know I'm drawing it the opposite way, but I was trying to not draw on top of that 4.5. So 4.5 is that leg. And 22.5 is this top angle up here. All I did was take this triangle and draw it over here. That's what I'm doing. Okay, so we already have our apothem, which is good because when we find the area, we'll have to plug that in. But we need to know our side length so that we can get the perimeter. So if we can figure out this, the short leg down here, then that will help us get our side length.
Okay.
You see that?
Yes.
Okay. So this one's not special. So what would you need to do?
Trig?
Yes.
This one.
Yeah. I'm going to put an X down here because that's what we're trying to find. So which trig function would you need to use? Sine, cosine, or tangent?
Cosine?
Opposite.
Wait, no, tangent.
Yeah, there you go. Tangent, because it would be from that 22.5 is the opposite and the adjacent. If it helps you, you can do the little abbreviation thing so you remember which one you're using. But so it'd be tangent 22.5 equals opposite over adjacent. So then you go to your calculator. Don't push it. Oh, don't push a button, buddy. All right, for X, what did you get?
1.9.
Yes. And I'm going to keep it, there's a whole bunch of decimals, but I'm going to keep 2 of them because the earlier you round, the more it's going to make your answer slightly off. I'm going to say 1.86 just to keep an extra decimal in there.
Okay.
So that is, or actually you still have it in your calculator. So that's half of the side length because that's just this. So while it's still in the calculator, you can do times 2. And that gives you the whole side length, which is 3.73, I guess, if you do 2 decimals. Are you with me on that?
Yes.
Okay. So now we have our apothem because they told us that, and we have one side length. So to get the perimeter, what would you do?
3.73 times 8.
And again, it's probably still sitting in your calculator. So that long decimal, you can just do times 8. Because the later you wait to round, the more precise your answer will be. So I got 29.82, I guess. Are you good on perimeter?
Yes.
Okay. So area, what are you going to multiply to get the area?
By 3.73. Wait, no, sorry, 4.5. And divided by 2.
Yeah. I see what you're saying. Sorry. Yes. And then what else?
Oh, and the perimeter. Okay, I got 67.1.
Me too. Good. Does the process of the whole deal make sense?
Yes.
How you go about it, I guess.
You want it opening up.
You don't want it? Okay. All right. If you want, you can try some of the others, and I can tell you if you got it right or not, if that's helpful. Or we can work more together, whatever you want to do. Or if there's other questions you have.
I just have like a question about 15.
Okay.
How would you go about solving it? Because, like, would you use cosine, tangent, or like a trig, or like the special triangles? Like, I don't know how you know what to use.
All right. So I put a center point.
Audible.
Thanks, buddy. And I know I'm going to have to get that right triangle.
Audible.
Hang on, Cruz. So I'm going to draw not very straight right triangle.
Here.
Which means that this part of it is going to be 10 because you cut that 20 in half. And then since I only have one number, what do I need to find first?
The central angle.
There you go. Yep. So it's got 5 sides.
So 72.
Which means in this triangle, it's not 72, but it is
36.
So then you have a triangle with 10 on the bottom and 36 up here. The line coming straight down is your apothem. So here's the apothem if it matches up with the little triangle I pulled out. So what would you use to find your apothem? You may have said it. I heard you say something, but it was really quiet. I couldn't understand.
Tangent?
Yes. Tangent, because it would be the opposite and the adjacent. So tangent 36 equals opposite over adjacent. And this one, just as a reminder, in 17, you did tangent 22.5 times 4.5 because it was in the denominator. But this one, you're still thinking cross multiply. Tangent 36 times A equals 10. So what you're really going to have to do is divide both sides by Tangent 36.
I got 13.76.
Yes. So that's your apothem because we were trying to find the apothem. That's the side we were solving for. So now you can use that apothem. And you need to find your perimeter. What would be the perimeter of that pentagon?
100.
You got it. So that's capital P. It's 100. So you can use those numbers to find your area.
Okay. I got 685.
685. Probably. I didn't round my apothem. I just used what was in the calculator. Let me try it with the rounded. That's probably why. Because mine was a little bit different. At 688. Did you do 13.76 times 100 and then divide by 2? Or times 0.5?
I don't know what I did, but I got 688 now.
Okay. Yeah, 688 is what I got too. That's the area. It asks for area and perimeter. So actually, both of those are your answer. For all of them, the A and the P are your, not the little a, the capital A and the capital P are your answers.
Okay.
We have a daily work quiz tomorrow that you get to use notes in your book on. And there will be questions like these, so I'm glad you're asking.
And for the quiz we took yesterday, can I take it during lunch?
Yes, that's fine. And you can, like always, you can use your spiral. And there were a couple questions, like the diagram people asked about. Not right now, okay? So I used like a colored pen and a marker to try to mark on the diagram. So you should be able to understand what it was showing.
Okay.
I wrote on your quiz what I had written on the board so that people could understand.
Okay, thank you.
Uh-huh. Oh, sorry.
Mom, where's the bowl?
I don't know, buddy.
Where's the bowl?
Do you want to try the other ones in that section and I can let you know if you got them right?
Yes.
Okay. Well, I'm going to mute it for a minute and let you try that. And then I'll, if you talk, I can hear you though. And then I'll check them for you.
Thank you.
Mm-hmm.
Could I check number 19 with you?
Sure. Let's see. 19. For the perimeter, it has 16.4.
Okay, I got that. And then the area is 20.5.
Very good.
Okay. Could you help me on number 25?
Yes. Let me. Oh, there it is. I think it's coming. Just a second. All right. So you are doing the shaded region. So it is a circle minus this, what is that, hexagon? So for the hexagon, you're doing exactly what you've been doing for the other ones. Draw your little triangle. And the reason it's showing you all those arcs and tick marks is because it's showing you it's a regular hexagon. If your shapes aren't regular, where all the angles are the same and all the sides, then this formula doesn't work. That's why they're showing you that.
Okay.
So 16 is the whole side. So just your triangle, it's 8. And then what would you do next?
Do you have to find the apothem?
Yes. So we only have one number. What other number can we find?
The central angle.
Yeah. So we use hexagons a lot. So the central angle is always 60, which means in the triangle 30. So it's a 30, 60, 90. You can use the little shortcuts. So how much would the apothem be?
8√3.
Yes. And in this one, because we're trying to find the area of the circle also, you need the radius of the circle because it's pi r squared. So if you find the radius of your hexagon, it's also the radius of the circle because it goes from the center and it touches the circle over here.
Okay.
So in your little triangle, you can find the other length, and so you'll have the radius of the you'll have the radius of the circle if you find that.
Okay.
So how much would the hypotenuse be of your little triangle?
16.
Mm-hmm. So now you've got all the measurements to find the circle. To find the circle, all you need is the 16 because the circle is pi r squared. So what would the area of the circle be? You can leave pi in there if you want until the end.
Oh, then it would just be pi 256.
Mm-hmm.
You got it?
All right. And then for the hexagon, what would you do?
Would you find the perimeter and then subtract? Or the area?
Yes, you need the perimeter and the area. You don't have to subtract yet. Use the perimeter as part of the area because it's in that formula, A equals 1/2 AP. So you need the perimeter to help you find the area. So what's the perimeter of the hexagon?
96.
Yes, so that's the capital P part. The apothem you have, and then you have that 1/2 out there also.
Stop, Rudy. Stop. Stop this here. Don't move further.
So what'd you get for the area of the hexagon?
I got 665.1.
Yes. So in the calculator, you can do 256 pi minus 665.1, and that would be the shaded region.
Okay.
Does that make sense?
Yes.
All right, 1 second. All right, what did you get?
I got 139.1.
I'm sorry. Yes. Very good.
Other one. I got other one.
Other questions?
Just for number 27, since there's not I found the circumference, but what would you do after you found that?
Let's see. Since I kind of cut that one off, let me get it again.
Okay.
Let's see. Okay, so your shaded region is just this tiny little, like the crust of the pie down here, kind of.
Mm-hmm.
So I think I like sweets too much. So when I look at it, I think in terms of sweets. I think it's like the whole piece of pie, but you just take the crust off. So if you were going to find the area of the whole piece of pie, like this whole piece, when it's a triangle with a curve on the edge, that's a sector.
Mm-hmm.
So the formula for the area of a sector, I'm writing it over here so I won't take up all the room. You can write it as a proportion, or you can do the area of a sector equals, not the arm. I was writing arm instead of arc for some reason, is the arc measure over 360 times the area of the circle. Remember that formula? Yeah. You use that on your quiz, actually, the one that you missed. So the area of the sector, and then you can, so that would be if it was all of this, like the whole piece of pie. But then you can take out, come on, you could take out the triangle. So you could subtract the triangle, so sector minus triangle. And that would give you just the crust left over. That makes sense?
Yes.
Yes, no, maybe. Like I said, it makes sense in my head, but please tell me if it's not coming across clearly.
But what do you mean by like sector minus triangle.
Okay, so the sector is if that whole thing was shaded in. My drawings are really bad. That's the problem. I'm going to use 28. 28 is like 27, except you can see the shaded part a little bit better. So a sector would be, instead of just that curve, it would be if everything was shaded in. If all of that,
Okay.
that's a sector. So what I'm saying is, if you find the area of the sector for number 27, if you found that whole thing, and then you took out, so you cut out the triangle. So took that out. What would be left is that little curved piece, which is what we're trying to find.
Oh, okay. Now I get it.
That makes sense?
Yes.
Good. Sorry. Sometimes I don't get my words together very well. So that's why over here to the far right, the area of this, if you can find the area of the sector using that formula, and then subtract the area of the triangle, that'll give you the shaded part.
Okay.
And for triangle, it's 1/2 base times height, just as a reminder. That's the formula for that. So for the sector, you need the arc measure, which we have, that 40. And you also need pi r squared. Wow, how nice. They gave us the radius. You don't even have to find the radius. You could, because you could use the little right triangle thing again and find it, but they tell us the radius. So for the sector, you're just plugging in the numbers.
Okay. So I got 452.39.
All right, let me see. Times pi times. It's not what I got. I got 50.27. This is what I punched in the calculator. I punched 40 divided by 360, and then I hit enter just to be sure it's doing it in the right order. Times pi, enter, times 144, because that's the radius squared.
Okay.
When I punched all that, that's when I got the 50 thing. Let me do it again. I might have hit a button incorrectly.
Okay, now I got that. I didn't multiply it by pi. I forgot about that, so.
Gotcha. All right, so for just the sector, like if the whole thing was shaded in, that would be 50.27.
Okay.
I'm going to put sector because that's what that would be. All right, for the triangle is 1/2 base times height. And this is where we're going to have to use the little triangle thing because the 12 is not the base or the height of that triangle.
Okay.
So pull out just a right triangle that we can work with, and 12 is the hypotenuse. So in the other ones, you had a polygon where you were counting the number of sides so that you could get the central angle. But this one, it already tells you the central angle because this 40, the arc measure down there, 40, this angle up here is a central angle because it touches the center. Okay, buddy. Okay, because it touches the center. So the central angle is 40. So in your little triangle, you cut it in half. Good. I think I cut you off. I'm sorry. What were you saying?
I was just saying it'd just be so neat to me.
Yeah. So then you can find your base and your height. Sorry. using trig. You can do one at a time.
Okay, so you'd use tangent to find the base.
You can't use tangent yet because the piece that you know, the 12, is the hypotenuse. So you have to use one of them that has hypotenuse in it.
Oh, okay.
Are you trying to find the base, you said? So I'll make that X. So if you're trying to find that, which one would it be?
Cosine. I mean, sine.
Sine. There you go. Opposite and hypotenuse. So the sine 20 equals opposite over hypotenuse. So where that little X is, what did you get?
Oh, I haven't typed it in yet.
Oh, okay.
$4.1.
Yes. And then to get the height, you could do trig again. You can do Pythagorean if you want, but you've already rounded, so it's just going to keep you rounding more and more. Uh-oh, sorry. Just going to keep you rounding more and more. So I'd probably just do trig again to keep some more decimals in there.
You do cosine.
Mm-hmm. Cosine 20 equals adjacent over hypotenuse. I'm going to put a y just so it'll be a different variable. Adjacent over the hypotenuse.
I got 11 point.
Yes. Okay, so we know that we want to do the sector minus the triangle. But if you look at the triangle we just used, so that we could have a right triangle, what we just found are the measurements for just this little red triangle. So if we find the area of that little red triangle, we need to double it so that it'll take out both of these triangles.
Okay.
Or any triangle is 1/2 base times height. So if you want to do the whole triangle at once, you want to do the whole thing, then it would be 1/2 the whole base. So you would have to double this number we got down here times height. So it doesn't matter which way, just know which triangle you're trying to eliminate before you start getting the area. Does that make sense?
Yes.
Okay. Do you want to do the little right triangle and subtract it twice?
Sure.
All right. So this blue triangle we drew over here, what would be the area of that triangle?
Is that just, so you just do 1/2 base times height?
Mm-hmm.
So 23.2.
Okay. So that is area of this.
Mom, look at my train.
So that's 23.2. This one is also 23.2. That gets rid of both triangles. Yes?
Yes.
All right. So I'm going to do 23.2 plus 23.2. So that's, I'll put triangles so it makes sense what we did. It's 46.4. Remember over here on the right, we were going to do the sector minus the triangle.
Yes.
So if you do that now, What do you get for this part that we forgot about down here? This is what we're trying to find.
3.87.
Yes. The process makes sense.
Yes, it just takes a while.
Yes, it does take a bit. You got to figure out what you're looking for first and which formulas will get you there.
What is a big apple?
It's a big apple, bud.
Mama.
Thank you.
You're welcome. You don't have any other questions?
No.
All right. If you think of something later or if you're looking over things for your quiz or something, you can email.
Okay.
And I hope your foot feels better.
Thank you.
You're welcome.
Bye.
Bye.